Welcome to EPG Pathashala. I am Ravi Korisettar, UGC Emeritus Fellow, Department of History and Archaeology, Karnataka University, Dharwad. In this presentation, I will be speaking to you on archaeology and its relationship with a variety of sciences in the subject of Indian culture and in the paper on principles and methods of archaeology. This is a two-part presentation which has an objective of making you to understand how scientific techniques are essential to enrich our knowledge of the past and to emphasize the need of scientific methods and techniques for a holistic reconstruction of the past, particularly the manner in which the hunter-gatherer societies gradually evolved from very simple way of life to more and more complex way of life. As you may be knowing, if you come across the manner in which the archaeology has been taught in Indian universities as well as outside India, it is taught as part of a course in history. It is also taught as part of course in ancient Indian history. It is also taught as part of anthropology and also geology. In all these disciplines, archaeology has found its own place. This also indicates the fact that archaeology, although it is an independent discipline, it has a place among all these related sciences such as anthropology, sociology, geography, psychology, and variety of other sciences, particularly physics, chemistry, biology, and so on and so forth. See, methods developed by all these sciences have contributed to shaping archaeology as an independent discipline which deals with the reconstruction of the evolution of human societies from simples to the more and more infinitely complex societies. As you can see from here, archaeology's relation with sciences is as old as the birth of archaeology itself. What it means is, in the beginning, archaeology was integral part of geological studies, and the evidence for the presence of human settlements going back to the lower Paleolithic times were first identified in geological context by geologists. Not surprisingly, the first discovery of Paleolithic tools was made by a geologist known as Robert Brucefoot from this site called Pallavaram near Madras. That actually laid the foundation for prehistoric studies in the Indian subcontinent. And rightly, Robert Brucefoot has also been regarded as father of Indian prehistory. Until the discoveries made by Robert Brucefoot from a lateritic gravel bed near Pallavaram were published in a scientific journal, not much was known about the earliest human settlements in the Indian subcontinent. He laid the foundation for understanding prehistoric archaeology and also establishing the relationship between geological sciences and prehistoric archaeology. It is common knowledge that archaeology, particularly pre- and prehistoric archaeology, cannot be practiced without help of a multitude of sciences. There are some books which have been published for the benefit of students of archaeology to train them in scientific methods. Some of the books, such as Science in Archaeology, that was edited by Brothwell and Higgs, followed by another book called Geoarchaeology by Davidson and Shackley, and Archaeological Geology, edited by George Rapp Jr. and Gifford, reveal the way a variety of sciences and scientific techniques have been helpful in archaeological investigations, and also very aptly summarize archaeology's dependence on various natural, biological, physical, chemical, and social sciences, as well as scientific techniques developed by modern day advances in technology. In the context of Indian archaeological research, two books entitled Quaternary Environments and Geoarchaeology of India, edited by S. Wadia, R. Korisettar, and V. S. Kale, and Indian Archaeology in Retrospect, Volume 3, which deals with archaeology and interactive disciplines edited by S. Setter and Ravi Kori Setter, provide you examples of application of scientific methods and techniques in Indian archaeological research. Application of remote sense techniques in Indian archaeology can be seen in Remote Sense and Archaeology, edited by Alak Tripathi. These books are useful for understanding the manner in which science, scientific techniques, scientific methods have been applied successfully in Indian archaeology, so that there is a holistic reconstruction of the life phase of ancient and extinct societies. Archaeological literature of the 21st century presents a plethora of terms indicating the increasing dependence of archaeological investigations not only on sciences but also on new techniques to facilitate reconstruction of the human past as completely as possible, as well as preserve the vestiges of the past for posterity. Conceptual developments of archaeology have also gradually led to identifying a series of subdisciplines with their own aims and methods that are mutually complementary. Subdisciplines of archaeological sciences include a series of subdisciplines either prefixing or suffixing the term archaeology, and they have now become specialized areas of archaeological investigations. They are such as environmental archaeology, geoarchaeology or archaeological geology, ethnoarchaeology, molecular archaeology, anthropological archaeology, settlement archaeology, geospatial archaeology, cognitive archaeology, marine archaeology or nautical archaeology, archaeobotany, archaeoethnobotany, archaeozoology, archaeochemistry, etc. Each of these subdisciplines have their own aims and have made it possible to recover the past as completely as possible, otherwise thought to be beyond the scope of contemporary archaeological methods. These methods, subdisciplines, have come into use and application at different points of time. In addition, several social sciences, humanities, and their methods have also been useful in developing archaeological theory and method. For example, geographical science has greatly contributed to improving field methods as well as new areas of investigation such as settlement archaeology. Cognitive archaeology deals with the mind of ancient man, for example, as applied to the study of prehistoric rock art. Here, rock art specialists have been making attempts to understand the mind of prehistoric man as reflected in the various themes reflected in the rock art panels belonging to both prehistoric and later prehistoric time period. Under the emergence of scientific archaeology, we would like to emphasize the way in which prehistoric archaeology has developed. At the same time, how scientific methods or scientific archaeology has helped in proper understanding of protohistoric archaeology, where there is distinctive absence of deciphered script. And in this context, a multidisciplinary approach has always been very helpful in understanding the political organization of early civilizations. And historical archaeology is also benefited by some of the modern techniques developed by space scientists as well as scientists working in areas facilitating understanding of the manner in which landscapes have evolved and landscape have undergone modification through time. These are broad areas of inquiry into the human past. The application of scientific methods and techniques is more common in pre- and protohistoric investigations. The face of archaeology has been changing rapidly with the emergence of the new archaeology in the 1960s. The new archaeology began to explore multiple ways of not only procuring archaeological data but also multiple ways of looking at the archaeological record and develop different approaches. This is in the context of the three stated aims of the new archaeology. The main aim of aims of the new archaeology has been reconstruction of culture history, reconstruction of culture change, and reconstruction of culture process. So these three aims can be fulfilled if a proper application of scientific methods are applied in archaeological investigations. The new archaeology also ushered in the employment of methods developed for the study of ethnic groups scattered across different parts of the world, as well as application of statistical techniques and use of computers for database management, so that large body of data can be processed to be able to synthesize our understanding of the archaeological record. It also argued that mere accumulation of systematic data was inadequate and emphasized on the need to go beyond collection and description, which was general practice among normative archaeologists. New archaeology further argued for scientific and anthropological approach, and in particular emphasized on ethnoarchaeology, in the sense that present is key to the past. If we can understand the manner in which ethnographic present can help us understand prehistoric context as well. One of the ways in which archaeology was certainly becoming more and more scientific was in its techniques. The post-World War period had witnessed refurbishment of field methods in archaeology, and the benefits of using aerial photographs to identify sites on macro scale, which are otherwise not visible on the ground. This had also led to an explosion in the number of scientific techniques. The use of computers, dating methods, geomorphology, geophysical techniques, environmental analysis, etc. This development of growth in the use of scientific techniques was a core concern of the new archaeology, and these techniques have provided more and more data of potential use in the study of the past. During the course of these developments, archaeology developed its own set of theory, methodology, and aims. While dealing with the recovery of the material remains, archaeology has developed a range of methods. It has borrowed and adapted techniques from other disciplines, has made them very much its own. Thus, archaeology different from history in that it requires material remains from archaeological sites, not just written descriptions of these remains. Now let us look at the relevance of scientific techniques. Exploration and excavation are the two major components of any archaeological research design. Without conducting exploration and followed by excavation, archaeologists have nothing at their disposal to be able to reconstruct the past. Systematic ground survey for locating archaeological sites, extent of archaeological activity, reconstruction of culture history of the settlement, etc. can be estimated prior to excavation and sometimes in lieu of excavation. As we all know, both exploration and excavation are time consuming and also involve large amounts of resources to be able to successfully identify archaeological context, also gather information in terms of the nature of these archaeological sites in relation to the landscapes with which they are associated. And that is one reason why before we embark on excavation, it is necessary to understand the site in totality, both in terms of surface features and the potential of the site for further excavation. There are other simple tests which are conducted prior to excavation, which include chemical analysis of soils associated with an archaeological site or with human activity in the landscape. It helps determine the duration and intensity of human activity in the past, reflected in the greater concentration of natural elements like carbon, nitrogen, and phosphorus in the soils associated with archaeological activity. These soils are called anthrosols or soils associated with human activity. Phosphate analysis is very common spot test that is carried out with simple equipments, including chemicals and what we call filter papers. Phosphate analysis for anthrozoites from a number of archaeological sites relating to Neolithic, Chalcolithic, and early historic sites have been carried out in India, and these have helped in identifying distinctive activity areas in in a given space at an archaeological site. Since the last World War, beginning with the use of aerial photos, a number of remote sensing techniques have also come into use, particularly in the field archaeological surveys. These are spin-offs from the advances in space research. Archaeologists searching for new sites use satellite images, drone operations, and geophysical instruments. These can be used in various combinations and are key elements of geographical information systems. Geophysical survey methods are part remote sensing, surveys, and non-destructive method of site investigation. It has found its application extensively in Indian archaeology. Resistivity surveying, magnetometry, ground penetrating radar, acoustic reflection, and thermal sensing are in use. Among them, resistivity surveying and magnetometry are most common. Now let us look at the way in which different sciences help in archaeological investigations, both in the field as well as in the laboratory. Geomorphology is one of the most important disciplines, which is very essential for understanding the archaeological sites in different geographical environments. Geomorphologists and archaeologists work together in archaeological projects. Their combination is essential at all stages of archaeological investigations, both while carrying out exploration as well as excavation. The application of geomorphological mapping at various scales helps in understanding the resource significance of various geomorphic units to ancient societies. For example, the availability of water resource, the availability of other natural resources which were essential for human subsistence in that particular region. It helps in seeking evidence for climate change, understanding the association of archaeological sites with fluvial, coastal, and desert environments, and with caves and rock shelters, as well as understand the effects of landform changes on archaeological sites. And that area has now been developed as a specialized area of investigation into what is called site formation processes. The landscape changes that have caused the state of preservation of the vestiges left behind by ancient societies have to be reconstructed in terms of processes that were responsible for the formation of an archaeological site. Geomorphologists have greatly contributed to understanding man-land relationship, be it fluvial landforms, coastal landforms, caves, and rock shelters. Now, in addition to that, the distribution of distinctive resources such as, for example, raw materials, particularly lithic raw materials, is very, very important for understanding the ranging habits of these ancient communities. Geological mapping around archaeological sites helps in recognizing a variety of lithic sources as well as ranging habits of ancient men. Principles of geological stratigraphy have been of great help in reconstructing culture history of archaeological settlements. Geological principle, particularly stratigraphy, refers to law of superposition of layers. In geology, it deals with various strata which are organized into a series of successive layers of geological formations. Similarly, in archaeological excavations, cultural layers can be identified as superposed upon one another based on identifying distinctive characteristics of the presence of variety of artifacts in different layers. Now, this also helps in reconstructing culture history. For example, the excavations carried out by Mortimer Wheeler at Brahmagiri for the first time employed the principles of stratigraphy and identified a succession of three cultural periods as Stone Age culture, Iron Age culture, and Andhra culture, meaning that there was continuity of occupation reflected in cultural development from the time of Neolithic period to the beginning of historical period at Brahmagiri. Later, this particular principle uh, came to be applied in all excavations that were carried out across the Indian subcontinent for reconstructing culture history of archaeological settlements. Geoarchaeological investigations also provide a means for reconstructing prehistoric and ancient landscapes, depositional environments, and paleoclimatic regimes. Collection of information on regional geological environments, local sedimentation, and stratigraphy are essential for interpreting ranging behaviors of the ancient settlers. If these features are correctly interpreted, the nature of human activity, whether ephemeral or long term, can be determined. Documenting sedimentary fabrics, textures, and compositions can be useful in activities in reconstructing activities surrounding the deposition of strata and to gaps in occupation. Simple field description of petrographic features of lithic raw materials, either for making tools or building structures, will allow location of quarry sites. For example, in terms of identifying quarry sites in the context of lower Paleolithic period in the Indian subcontinent, the best example comes from the site of Isampur in the Hunski Valley of Karnataka, where the, the, the prehistoric stone tool manufacturing workshop has been brought to light through excavations, and this excavation has revealed the various stages in the way these raw material was procured, modified, and then finally finished artifacts were produced. And this particular site has been dated to about 1.2 million years ago. The other scientific disciplines which can help us understand the environmental conditions at the time of human occupation at any given site can also be reconstructed by applying palynological methods. Palynology is broadly defined as the study of pollen and spores from living and fossil plants, including their dispersal and application in paleoecology. Paleoecology refers to understanding the relationship between and among variety of natural phenomena in an ancient context, as well as in the present context as well. Paleopalynology and palynology are two distinctive disciplines which deal with different time periods. Palynology is useful in both stratigraphic and paleoecological studies and is applicable to geology, ecology, and in the field of botany. Paleoecological studies based on pollen analysis have been especially important in archaeological studies because it helps in reconstructing contemporary environment, particularly variety of plant food resources that were available or variety of plants that were growing during the time when human occupation took place at a particular site. The study of pollen and spores preserved in archaeological deposits are of great help in reconstructing contemporary vegetation and climate, as well as extracting valuable information on the relationship of prehistoric people and their environments. Identification of cultigens, those plants which were suitable for cultivation by ancient societies, dietary information, the type of food, plant food these people consumed, site seasonality, because plants have their own seasonality and their presence at a particular site also helps us relate the occupation of the site and the season during which time the occupation took place. Anthropologically related questions can be addressed by the analysis of pollen grains preserved in archaeological sites. Changes in the regional vegetation and climate may be of significance in interpreting archaeological evidence. Chemical analysis of soils, as I mentioned earlier, associated with human activity in the landscape helps determine the duration and intensity of human activity in the past, reflected in the greater concentration of natural elements like carbon, nitrogen, fluorine, and phosphate. Phosphate analysis of anthrosols from a number of archaeological sites of Neolithic, Chalcolithic, and early historic sites have been carried out in India. The chemical study of analysis of soils associated with human activity is an important application of chemistry in archaeology. The soils associated with archaeological sites are called anthrosols, or soils altered by human activity as compared to natural soils. The extent of chemical alteration of these soils relates to both intensity and duration of settlement. Plant nutrients, organic matter, oxidation reduction characteristics, pH values, and exotic contaminants are chemical soil factors reflecting human activities that can be quantified. Chemical analysis designed specifically for anthrosols, particularly phosphate analysis, can be applied both qualitatively in the field and quantitatively in the laboratory. Application of remote sensing in field archaeology. Remote sensing refers to the branch of science which deals with objects through measurements made from a distance. It uses electromagnetic radiation as the medium of interaction. Apart from visible light, sensors to detect electromagnetic radiation extending from the ultraviolet to the range of infrared and microwave regions are also used for remote sensing. Since the last World War, beginning with the use of aerial photos, a number of advanced remote sensing techniques have come into field archaeology as spin-offs from development in space and aeronautic science. Archaeologists searching for the new sites use satellite images, drone operations, and geophysical methods. These can be used in various combinations and are key elements of geographical information systems. Geophysical survey methods are part of remote sensing surveys and a non-destructive method of site investigation. It has found its application extensively in Indian archaeology. Resistivity surveying, magnetometry, ground penetrating radar, acoustic reflection, and thermal sensing are in use. Among them, resistivity surveying and magnetometry are most common. A series of workshops to train up and coming archaeologists in India have been organized by IIT Kanpur and National Remote Sensing Agency in Hyderabad. In summary, this is the first part of introducing how variety of sciences and techniques are useful for archaeological investigation as well as interpretation of archaeological data. Primarily, the focus here was on how various techniques were useful in conducting exploration and identifying archaeological sites without investing more time and resources, as well as some methods which also help in minimizing archaeologists' effort to further plan for excavation projects at archaeological sites. For further information on this particular module, please visit our website as well as e-text quadrant of this particular module. Thank you.